Hi everyone, this is Alice and I'm going to go over the example problems from the normal distribution handout. So if you go to Alspace Resources, click on Class Handouts and Links, Statistics and Probability, and then Normal Distribution. The first link is a review of the 68, 95, 90, 99.7 rule that we talked about today. And if you take a look at the last image, it kind of breaks it down by percentages based on standard deviations away from the mean, which is derived from the 68, 95, 99.7 rule. So let's go ahead and take a look at the first example. So for example 1, we have the mean height of players is 184 centimeters and the standard deviation is 5 centimeters. So what is the percentage of them likely to be taller than 189 centimeters? So the first thing I always like to do is sketch a graph. Okay. And we're assuming that the distribution is a normal distribution. So the middle of the curve is going to be the mean, which is 184 centimeters. Okay, so it's symmetric, so this serves as the axis of symmetry, and right around the point where the concavity changes is going to be one standard deviation away from the mean, and in this case it's 5 centimeters, so we're going to add 5 to get 189, subtract 5 to get 179, and then repeat, add 5, 194, then 199, subtract 5 to get 174, and 169. Alright, so now we want to know what percent of them are likely to be taller than 189. I'm going to go ahead and let my random variable x be the height of players. And so therefore for letter A, the probability that the height of players is taller than 189. That's what we're looking for. And we're not going to use a calculator, we're just going to use simple arithmetic. So in this case, 189 I can see is one standard deviation above the mean here. And we want to know what percent are greater than 189. So we're looking for this area right here. So we know that the mean is the 50th percentile, and we know that this area is 0.34, so we know that this area below the 50th percentile is 0.5, and the entire area is 1. So we're going to go ahead and take 1, which is the entire, which is the probability of the whole distribution, and we're going to subtract 0.5 and 0.34, which is 0.84, to get the 0.16, which is the percentage of them likely to be taller than 189. Okay. For B, we want to know the probability of being taller than 179. So 179 is here. Okay, so I'm going to do another little sketch for B. So 179 is right there, and we want to know what is going to be the probability that the height, the percentage of them is greater than 179. So again, we know that this here is the 50th percentile, and this right here is 0.34. Okay. So therefore, we know that we've got 0.5 and 0.34, and we add those together. Because the 50th percentile means the mean was actually less than 50% of the values, as well as being greater than 50% of the values. So we're going to go ahead and add to get 0.84. Okay, for letter C, we want to know the probability between 174 and 199. So we have, again, a little sketch with 184 in the middle, the mean. We've got 174, 2 standard deviations away, and 199, which is 3 standard deviations away. So I know that within 2 standard deviations, oh, and we're going to be in between. So we want to know the area in between these two. So we know that within 2 standard deviations is 0.95. And then we have to add this little area right here. And between the 3 standard deviations is a 90.997 to get the area of both this area and this area, right, between the second and the third and the second and the third standard deviations on both sides of the graph of the mean is going to be 0.4047, which is 0.997 minus 0.95. And if you take that and you divide by 2, then you're going to get this little area right here, and it ends up being 0.0235. I'm going to go ahead and add 0.95 plus 0.0235, which was 0.047 divided by 2 to see where that came from, and that's going to be 0.97235, which I'll just round to 0.972. Okay, for letter D, we're going to go ahead and do the probability that x is greater than 199, and this is to the right of the third standard deviation, and therefore this area along with the area to the left of the third standard deviation, which is 169, represents only about 0.1 minus 0.997 of the population, which is 0.003, and therefore I'm going to take this number, 0.003, and divide by 2, because we just want the area over here, which is greater than 199, and we're going to get 0.015. Okay. In other words, it is very unlikely that players are going to be greater than 199 centimeters, given that the mean height is 184 and the standard deviation is 5. Now, suppose we are allowed to use a calculator. So let's take a look at example 2, and then we'll walk through how to use a calculator. So given the same distribution, we're going to find the probability that a randomly selected player is at least 186 centimeters tall. I always like to start with a sketch, and so I'm going to go ahead and do a quick sketch of the problem. I know that the mean is 184, and I want to know at least 186 is going to be 186 or more, or high, or greater. Okay, so that's what I'm looking for, is the probability of this area under the curve. Okay, so what is the probability that a randomly selected player is going to be at least 186? So I will go ahead and write it as the height will be greater than or equal to, and it doesn't matter whether you include the equal or not for normal distributions, is 186. Well, in this case, it's at least. I will use the equal sign here. Okay, so we're going to go to our calculator, and again, start with menu, statistics, and now we're going to do distributions since we're talking about normal distributions. And in this case, we're going to use the normal CDF, which stands for the cumulative density function. So let's go ahead and click on this. Now we need a lower bound and an upper bound. So let's take a look back at the graph. So it looks like our lower bound here of the shaded area is 186, and the upper bound is really positive infinity. So the lower bound is 186. The upper bound, as you saw, once you get past 3 standard deviations on either side, the percentage is minuscule, and so therefore I'm just going to pick a big number, and I'm not too worried about exactly how many zeros, but just a lot. And the mean here is 184, and the standard deviation is 5. Okay, so we see that the percent would be 0.345 if I'm rounding to 3 significant figures. And that kind of makes sense since we know that it looks like it definitely has to be less than 50%. Okay, so let's take a look at letter B. Between 180 and 190, again, I'm going to do a quick sketch. Okay, and for the mean, I have 184. And between 180 and 190, so I'm going to actually sketch, and it looks like I have both a lower bound and an upper bound, which are finite numbers. So I'm going to go back to my calculator, and you can copy and paste. I know I have the same mean and standard deviation, so my lower bound in this case is 180, my upper bound is 190, and then I get 0.673. 0.673. So I'll write down the probability before I forget. Okay, let's go ahead and write down the fact that x, the random variable, was in between 180 and 190. Okay. And the last one, letter C, at most 170. Probably the hardest part of this is figuring out what at most means. So again, for students, I'm going to sketch 184. At most 170 would be somewhere down here, and at most means 170 or less. Okay. So in this case, I'm going to write down that the probability is the random variable x is less than or equal to 170. So I can look at the graph, which is why I like to sketch it. The lower bound is actually negative infinity, and the upper bound is 170. So let's go to our calculator, and I'll go ahead and use menu, statistics, distributions, normal CDF. The lower bound is, this is a very, very, very small number, negative 9 times 10 to the 999th power. This is exponential, so that's a very, very small number. And so you could also just put negative like 1,000,000, and that will work. And the upper bound was 170. Okay, change the mean again, 184. The standard deviation, 5. And again, very small probability, 0.00256. 0.00256. All right. Now let's go ahead and go over the steps. The first thing we did was we pressed menu, and then we pressed statistics. I think it was that, wasn't it? Menu, statistics, right? And then distributions, and then normal CDF. distributions, and then normal. I'm not sure if it's norm or normal. Let's take a look here. Menu, statistics, distributions, normal, CDF. I think for the TI-84, it may be norm CDF. We can check real quick. So let's see here. We've got second var for distribution. Oh, in this case, it's normal CDF as well. And you can see that it looks very similar to the TI Nspire. Okay. All right, so let's go ahead and record that normal CDF. Okay, cumulative density function. All right, let's go to the back, the next page. Okay. Given the same distributions as example 1, suppose we would like to separate the tallest 5% of the players from the rest of the players. How do we determine the minimum height of the tallest 5%? First, draw a sketch. Okay. So now we're actually trying to find the value of the data point given the probability, okay, or the area underneath the curve. So here's my normal curve. Again, I know that 184 is the mean. Okay. And I want to know what is the height, which is that separates the tallest 5% from the bottom 95%. So that's going to be pretty tall over here. So this area right here is going to be 0.05, and this area right here is going to be 0.95. Make this a little darker. Okay, so I'm going to call this K because I don't know what it is. Okay, so in order to do this, I'll go ahead and write down what I'm looking for. So I want to know what is the height, random variable X, where in this case we don't know what the K value is. Now, before we fill in the rest, we're going to use a function called inverse norm on your calculator. And what it's going to ask for is the area, and then the mean, and then the standard deviation. But the area is always going to be the area to the left of the value that you're looking for. So here we have 0.95, which is the area to the left of K, and 0.05, which is the area to the right. So we need the area to the left. Okay? So in this case, it's going to be 0.95. So in this case, we know we have to use a less than or equal the value we're looking for. So again, when we are given the area or the probability or the percent, we want to look for the value that separates that probability from the rest of the population, we have to always take into consideration area, which is to the left. So even though they gave us 5%, we have to type in 0.95 because that's the area to the left of K. So let's go ahead and go to our calculator. And in this case, we're going to use inverse normal. And the area here is 0.95. The mean is 184. And the standard deviation is 5. So the height that separates the tallest 5% from the lowered 95% is 192. All right. So we're going to take a look at the last problem now. And this was actually called inverse normal. we went to menu, statistics, distributions, inverse normal. So it was statistics, distributions. That's probably the step you have to remember to do. Okay, and then inverse normal. So in this case, our area was 0.95, our mean was 184, and the standard deviation was 5. Okay. Last problem, a college professor determines that no more than 80% of this year's math candidates should pass the final exam. The exam results were normally distributed with mean of 62 and a standard deviation of 13. So find the lowest score necessary to pass the exam. So I'm going to go ahead and again sketch a graph. Okay. The mean here is 62. And just be careful you don't mix the exam score with the probability, which is here 0.8 that we're looking for. And so in this case, we want the score, which is necessary to pass, and 80%, no more than 80% should pass. So whatever the score is, 80% of them will pass, which means it's going to be somewhere to the left, because if you're to the right, left of the mean, because if you're to the right, then you're going to pass. So this represents the students, the proportion of students that passed, and this represents, which here is 0.2, the percentage that didn't pass. And we want to know what is this score right here that separates the two groups. Okay, so I'm going to go ahead and write down the probability that x is less than or equal to k. Here is 0.2, okay, because we're actually looking for this area right here. I'm sorry, we're given this area and we're actually looking for this k. So I'm going to go back to the calculator and do inverse normal. Here the area is 0.2 because it's always to the left of the k value we're looking for. The mean here is 62 and the standard deviation is 13. Okay, and then we get a 51 test score. 51. And so just let me know if you have any questions, and hopefully this will help you do the other problems.